Hello, dear students. This is Mr. Hogr, a chemistry teacher at Zhyar English High School. I'm really excited to guide you through all the grade 12 chemistry chapters right here on Zhyar TV. So make sure to have my booklet and the question bank ready also. So you need both of them. Be careful, okay? The booklet and the question bank. And then use these videos like your private teacher. That's why I prefer to stay focused and follow along and write the notes. Inshallah, these videos will help you to reach the marks you are aiming for. So let's begin right now, okay? Because this is the first lesson, so I don't like to start directly to study directly the chapter 1, because we have to revise something really important, like stuffs that you learned in grades 10 and 11, okay, which are really important. So as I said, please, we have to review something really important, like how to write the chemical formula, what are the ions, including monoatomic ions and polyatomic ions, okay? Because, you know, this kind of revision will be a shed light for too many other chapters, like chapter 1, chapter 2, chapter 3, chapter 6 mainly, chapter 7, okay? So as I say, these are really important. The first thing, which is a combination between the grades 11 and 12, the term of the concentration, okay? From now on, anytime if somebody asked you what mean by the term of the concentration, okay? What mean by the concentration? Immediately, without thinking, just say, Mr. Concentration, it means the amount of solute. The amount of what? Solute in given amount of solvent or solution. The point is the amount of solute. Look, let me give you some general idea about the concentration. Concentration, okay? Concentration, first of all, there are two types of solutions. Solutions that contain more amount of solute. So we call this kind of solution as the concentrated, okay? Concentrated. Very good. So if I say the concentrated solution, it means it has been prepared by the dissolution of more amount of solute. But if we use less amount or trace amount of solute, so this kind of solution is called diluted or diluted, no problem, diluted one. But if I say concentrated or diluted solution, okay, you know, it will provide a little idea about the amount of solute, but we don't know the exact amount in some numbers. Like if I say, assume that we have a concentrated sugar water solution. So, okay, Mr. Concentrated solution, it means it contains more solute, but we don't know the exact amount of solute, okay? If it's, we know it's more, but by some numbers we cannot identify. That's why if you try, if you want to identify the exact amount of solute, we have two different expressions, which are molarity. Molarity, also called molar concentration, and the next one is molality. Molality, okay? The difference is R by L, okay? Molarity is symbolized by the big M, capital M, but molality, small italic m, okay? These two different expressions are used to identify, to calculate the exact amount of solute in given amount of solvent, okay, or solution. Look, concentration, it means it's a measure of the amount of solute, okay? This is the most important part of the concentration. As I said, we have two different expressions, which are molarity and molality. Okay. Molarity, what is the molarity? Look, as I said, we have molarity and molality. We need molarity in around 4 chapters, but molality, we need molarity only in the section 2, okay? Section 2, chapter 1. So for today, as a quick revision, I will ignore, okay? I will ignore molality. We don't need molality, okay? That time, once we get in chapter 1, section 2, in there, we will study the molality. What is the molality? And I'll explain every single point about the molality. But for now, it's too early to talk about this. We only need molarity. For now, as I say, well, molarity equals to mole of solute, look, mole of solute over liter of solution. Be careful. What is the molarity again? Look, I will write the formula of molarity. Molarity equals to mole over liter. But liter here, it's for solution. Mole, it's for the solute. Good. Molarity, what is the molarity? Repeat this after me. Molarity, mole over liter. How about the mole number? Mole. Mole equals to mass per molar mass. Nice. These are the two rules that are coming together always. Like son and father. In anywhere, if we have mole number, it's okay to have something like molarity, then we will make some conversion between them. Good. The unit of measurement, the units are really important. Molarity, the unit of molarity is mole over liter. Or sometimes we will have the concentration by some numbers like capital M. Good. About the mole. Mole is M-O-L. Just remove the last letter, which is E. Good. About the volume. Volume can be given by liter, cubic centimeter, or milliliter. Be careful. These are the most common units for the volume. But the center one is the liter, because in the molarity formula, we need to use liter. So we have to convert them, cubic centimeter or milliliter, if we have them into liter. How to do this? Conversion of liter into them, we have to multiply the number by 1,000, but the opposite way. The given number must be divided by 1,000. About the mass. Mass can be measured by grams or kilograms, no problem. Grams can be turned into kilogram by division, divided by 1,000, and kilogram into grams by multiplication. Multiply the number by 1,000. Very easy, right? Good. About the molar mass. Molar mass is measured by grams per mole. This is the unit of molar mass. Molar mass is measured by grams per mole. So the following units are really important. Let's have some examples because we have to practice about them. As I say, the units are important. Okay, look at this. Find the molar mass of sulfuric acid. You know how to calculate the molar mass. Sulfuric acid is, the formula is H2SO4. This is the chemical formula of sulfuric acid, H2SO4. You should remember this always. Never forget this. We have this one almost in 8 chapters. Sulfuric acid. This is the king of, I think it's a king of chemical formulas, of all chemical formulas in grade 12 of chemistry. Well, look, how to calculate the molar mass of sulfuric acid, H2SO4. First, let's count the number of the atoms per any formula unit of sulfuric acid. We have 2 hydrogens, 2 times hydrogen, plus, how about sulfur? 1 times sulfur. This is a very basic calculation in chemistry. Plus, oxygen, we have 4 oxygens. So 4 times oxygen atoms, okay, which are 4 oxygen atoms, I mean. Then substitute the atomic masses because for the calculation of the molar mass, atomic masses must be given. Look, the atomic mass of hydrogen is 1 times 2, stay 2. Then 1 times 32 for the sulfur atom, 32 plus, okay, oxygen is 16, times 4. 16 times 4 equals to, I think it's 64. Yeah, it's 64. Then take all together, the final answer is 98 grams per mole. Okay, Mr. Molar mass of sulfuric acid is 98 grams per mole. What mean by this? Once we have a molar mass of any given formula, it means 1 mole, look, 1 mole of a given formula equals to the same number of molar mass, but by grams. What mean? Again, okay, I'll repeat this kind of information. Look, molar mass of sulfuric acid is 98. It means if we have 1 mole of sulfuric acid, the mass is 98 grams. Okay? The mass is 98 grams. Example, molar mass of H2O is 18 grams per mole. It means 1 mole of water equals to 18 grams per mole. 18 grams, I mean. Good. Let's solve an example about the molarity. The molarity. However, we have a solution here, but I will resolve the question from the first. Look, 0.4 grams of sodium hydroxide. This is the mass. Sodium hydroxide, hopefully you know the formula, which is NaOH. Okay, good. Is dissolved in enough water to make exactly 200 milliliters. Oh, mister. Volume is given in milliliter. So do we have to do something about this? Yeah, exactly. As I say, the center unit is liter, not milliliter. So we have to convert this into liters. How to do this? By division, okay? Divide the number by 1,000, you'll get the right value of liter. So liter equals to milliliter divided by 1,000. So liter equals to 200 divided by 1,000. The result is 0.2 liters. Very good. So liter is ready. And look, calculate the molarity. Calculate the molarity, please. It's not your time. Calculate the molarity of solution. Find the value of M. Okay, what we have to do if we have something like this, which is really a confusing question, we have too many different numbers. What to do with this? What is the starting point in any question like this? I prefer for you, please, always start from the unknown. From what? From the unknown. Start from the unknown. Look, the unknown is molarity. Write the formula of molarity. What is molarity? Molarity equals to mole over liter. Now liter is ready, okay? But we don't have anything about the number of mole. Look, but there's something else. We can turn it into number of mole, which is mass, and we can find out molar mass. So the problem is, we need to find out the molarity. We have liters, we don't have mole number. But how to calculate mole number? Easily, mole equals to mass per molar mass. Get? Mass per molar mass. Very easy. About the mass, which is 0.4, but again, we don't have molar mass. Okay, what are you waiting for? Calculate the molar mass very easily. Look, molar mass of NaOH. Since the compound is sodium hydroxide, so the formula is NaOH. Molar mass equals to 1 times sodium plus 1 times hydrogen plus 1 times oxygen. So the final answer is 40 grams per mole. This is the molar mass of NaOH. Okay. Now let's find out the mole number. 0.4 divided by 40, so mole equals to 0.01 mole. Very good. Now the mole number is also ready. Let's substitute this number here and liter here also. Molarity equals to, mole number is 0.01 divided by liter, which is 0.2. The final answer is 0.05 molar. This is the molarity of solution. Okay, again, I'll repeat the question from the first. Start from the unknown. Write the formula of the unknown. Then we will see what is the given information and which one is the unknown. We will prepare all the requirements for the unknown. Then you have to run the equation very easily. Use your calculator. I don't know if it's pink or black. Normally, girls are using pink calculator and boys are using black calculator. No problem with this. The point is, you have to prepare all the things for the unknown. Then run the equation, you'll get the right answer. It's very easy. I'll leave this question for you, okay? These are nothing really. I don't like to waste our time. And as I said, molality, it's not the right time to talk about the molality, please. We will leave molality for the second section of chapter 1. In there, I'll explain everything about the molality. And this question, it's about the molality. This one also is about the molality. List of the ions. Look, the ions, the most important, the superhero of chemistry, the alphabet of chemistry. Without the ions, nothing can be done, believe me. You're gonna get a very big problem. You're gonna face a very big problem. So without the ions, I mean. But actually, really, they are nothing. Once you memorize the ions, everything will become very simple for you. So please, you have to memorize all the ions. I cannot do anything for you. Okay. Assume that now I will read the ions. Okay, stay with me. Look, lithium is +1. Group 1 elements are positively charged 1 ions. Sodium +1, potassium, rubidium. Doesn't make any sense. You have to memorize by the end of this. So please memorize all the ions, as I said, including polyatomic and monoatomic ions. I don't talk about any of them. Let's solve some questions about the chemical formula. Write formulas for the following compounds. The first one, barium carbonate. Okay. What's the chemical symbol of barium? Ba. The charge is +2. Good. Carbonate, CO3, -2. So since they have the same amount of the charge, I didn't say they're the same charges. The same amount of the charge. It means you have the same numbers, but with the opposite charges. Yeah, arithmetic signs, I mean. So just combine them. BaCO3, the final answer. Ammonium phosphate. What is ammonium? Ammonium, NH4 plus. Phosphate is PO4, -3. Simple cross product, okay? Like a scissor. 3 to here, 1 to here. It will become NH4 by 3 PO4. Ammonium carbonate. This is ammonium. NH4 plus carbonate is CO3 -2. Cross product again, you'll get NH4 by 2 CO3. I know the overall charge must be 0, but we learned this kind of thing in chapter 7. Okay, potassium permanganate. Potassium permanganate, this is potassium, okay? Permanganate is MnO4, -1. The overall is KMnO4. One by one, just combine them. Because we have the same numbers, so just combine them. Sodium carbonate, sodium is Na, +1, carbonate is CO3 -2. 2 to here will become Na2. 1 here, CO3. Easily. About the stock system, look at this. This is the stock system. Mercury, chloride. This is mercury. Hg +2. Because we have mercury II, it means the charge is +2. Chloride is Cl -1. Together, it will become HgCl2. But my dear, we have a very special case. So stay with me. Look. For the mercury, look at this. Mercury +1 chloride. How to write this chemical formula? This is a special case. It's only for the mercury I. It means mercury positively charged one. Only for this. Not mercury +2. Be careful. Well, mercury is Hg. The charge is +1, so you may write this formula like this, which is wrong. Mercury +1, you know, we have this ion as the polyatomic ion. Okay? Mercury +1 is very unstable, is a very unstable ion. That's why two mercury atoms are combined together to form Ag2 +1 with +1 +2. However, the charge is +2, but it stands for +1. So you write mercury 1 like this. This is mercury 1. The charge of mercury inside of this ion is +1, but we will write as the dimercury ion. The overall charge is +2. It means we have positive 2 for two atoms of mercury. So for any atom we have +1. Now the mercury +1 ion will be like this. Ag2 +2, and chloride is Cl -1. Look, only transfer the charges. Just transfer the charges, you'll get the right answer. 2 to here, 1 to here. Since the charge of the chloride is 1, so we'll take the first ion as it is. Ag2 times 1 will be the same. 2 to here. Okay, you may often ask, Mister, is there any simplification? This is impossible to simplify, to cancel the numbers here. Because, you know, look, try to have this as a very important note. Only the numbers that came from the charges are going to be simplified. As I say, only the numbers that came from the charges can be simplified. But here, this number 2, we have this by the combination of two mercury atoms. So it's impossible to cancel them. The compound will stay like this. This is mercury monochloride. But for the mercury positively 2, we'll solve that one as the other examples. As I say, this is a special case only for mercury +1. Good. The classification of the compounds. Stay with me, my dears. This is another important topic. Actually, this is a super important classification in chemistry. Let me have a sip of water. Okay, sorry. Okay, let's classify the compounds. Look, compound. Normally, compounds, it's a combination of two or more different atoms together by ionic or molecular bonds. No problem. The point is, we should have 2 or more different atoms. Compounds are classified into 2 main categories. The first one, ionic. Ionic compounds. Very good. Ionic compounds. Ionic compound, it means there is a positive ion and negative ion. Look, ionic compound contains positive and negative ions. Good. And between the positive and negative ions, there's an attraction which is called ionic attraction, like this. This is called ionic attraction. Ionic attraction, it means ionic bond. So both names are the same. Ionic attraction, it means ionic bond. It's between the ions. Okay, because we have positive and negative poles, so the ionic compound must be polar also, which is a water-soluble compound. Very good. And now there's a further classification for the ionic compounds. Ionic compounds are further classified into the salts and strong bases or strong bases. Strong bases. Strong bases. Very good. So as I said, ionic compounds are classified into the salts and strong bases. So if I say explain salt, salt is an ionic compound that contains of ionic assembly of the cation and anion. Same thing true for this. Strong base is an ionic compound that contains of the cation and anion that are assembled together through the ionic bond or ionic attraction. Be careful. Ionic attraction and ionic bond, they're both the same, as I say. Please, they're both the same. Okay. So both are electrolytes. Wait, there's a very important point here. Later I'll get back to this. Okay. The second class of the compound, which is called the molecular compounds. Molecular compounds. Look, compounds are classified into molecular or ionic. For the ionic, there is a cation and anion. Both are assembled together through the ionic bond, which is also called ionic attraction of the ions. Okay? There's a further classification for the ionic compounds, which are salts and strong bases, or strong bases, strong base. Okay, normally I will say strong base. I love this name, base, because you know my sister has this name. And both are electrolytes. Okay, molecular compounds are further classified into. But Mister, you say ionic compounds are contain cation and anion. But how about the molecular compounds? Okay, they contain molecules. Let me select the same color here. So they contain molecules. Good. How about the bond? The bond here is ionic bond, but here it's a covalent bond. Okay. من همیشه او حزم بداية مشكان ببيتي capital بنسم. I know grammatically it's a wrong way, but you know, for the sake of styling, I'll write the first letters in the capital way. Good. Okay. So all the ionic bonds are polar. All of them are polar. Is it true for the covalent bonds? All the ionic bonds are polar. Is it true for the covalent bonds? No. We have some of them that are polar, some of them that are non-polar. So molecular compounds are divided into non-polar and dipolar. What's the difference between them? Polars, they have positive and negative poles, but here, no. Non-polars, no, okay? And there's a quick way to recognize the polars. If they dissolve in water, that means it's a polar substance. If it's not, it's a non-polar substance, because water is a king of the non-polars. Okay. Non-polars like oil, kerosene, fat, benzene, toluene, and so on. Well, about the polars, there's a further classification. Polars are classified into, non-electrolytes and the electrolytes. Non-electrolytes and electrolytes. From now on, there are two main categories, two main classes for the non-electrolyte molecular compounds that are polar, which are alcohols and sugars. You know alcohols like ethanol, methanol, even glycol also, sugar, glucose, sucrose, and so on. For the electrolytes, acids including strong acid and weak acid, strong acid and weak acid, weak base. Let's begin from the first. Compounds are classified into ionic and molecular. For the ionic, we have salts and strong bases. Both are polar, electrolyte. They contain ionic bond, which is also called ionic attraction. So all the ionic compounds are polar. But for the molecular compounds, some of them are polar, some of them are non-polar. The non-polars like oil, kerosene, toluene, benzene, so on. About the polars, we'll classify the polars into the electrolytes and non-electrolytes. Non-electrolytes like alcohols and sugars. But the electrolytes, strong acids, weak acids, and weak bases. Look, let's have some of the most sensitive questions. Look, these are polar, true? These are also polar. They are both polars. Electrolytes, they are also electrolytes, right? But why do we separate them? Why don't you write them together as a single class? Why do we separate them? Look, both are polar, here and here. Both are polar, both are electrolytes. Electrolytes, of course. But why do we separate them? Okay? Because of the behavior. After their dissolution in water, they behave in a different ways. Look, after the dissolution of the ionic compounds, there will be a reaction which is called the dissociation. So they dissociate, or the disassociation also. Ionic compounds are dissociated in water, but the polar molecular compounds that are electrolytes, they ionize, which is called ionization. How about here? They don't ionize. Okay, mister, how about the nonpolars? Nonpolars are also non-electrolytes. So these classes are both non-electrolytes. They don't ionize. The difference is this is polar, this is non-polar. Okay, look. Ionic compounds are dissociated in water, which are strong bases and salts. But molecular electrolytes are ionized in water, which are acids and weak base. Good. So let's have a quick revision for the electrolytes. Now, electrolytes, generally, the electrolytes are, look at this, salts, strong bases, weak bases. Okay, strong acid and weak acid. Look, we have 5 main groups of the electrolytes. 1, 2, 3, 4, 5. What's the difference between them? 2 of them are ionic, which are going to dissociation. But 3 of them are molecular. Molecular, which are ionized. They ionize in water, or ionization. Okay? So generally electrolytes are acids, bases, salts. Weak acids, weak bases, strong acids are molecular. They are ionized. But for the salts and strong bases, they're dissociated. Good. In water, of course. I have explained every single point here. But now, you know, we have too many examples here. Later, you're going to be familiar with the examples. Very good. Yeah, this is the one that I explained it just now. Non-electrolytes also, I have explained it. We have some questions here. Stay with me. Okay. These are Zhyar-like questions. Again, I need some water, please. Water is a tasteless substance, but it is the most delicious thing for me. Okay, look. The most delicious thing, yeah, really. The molecular compounds contain. Look. About the molecular compounds. Are they polar or non-polar, or can be both? Some of them are polar, some of them are non-polar. Okay, look. Non-polar covalent bond? Yeah, true. Polar covalent bond? Yeah, true. But we have both. So polar and non-polar covalent bonds are present in the molecular compounds. True. Another question. Which of the following... look at this. I'll get to you. Which of the following is a non-polar molecular compound? Let me hide the answer key here. Okay. To prevent cheating. Be cheatless, please. Okay. Which of the following is a non-polar? Non-polar molecular compound. Non-polar. What are the non-polar molecular compounds? Benzene, kerosene, oil, toluene, CCl4. Okay. Look. This is benzene. Write this name. Benzene. So from now on, you should recognize the formula of benzene. 6 is H6. Benzene is a non-polar molecule. True still. Glucose. It's a polar. No, we don't need this. How about this? Glycol. This is ethylene glycol. Try to memorize this name also, this formula. Okay? This is a chemical formula for the glycol. This is also a polar. It's a type of alcohol. How about the ethanol? There's also a polar molecule. Polar, it's both polar and non-polar. So this is the non-polar molecule. This is called weakly polar substance. You have studied this in grade 11, of course. Look, a molecular compound that is electrolyte. Electrolytes. Okay, that is electrolyte. What are the molecular electrolytes? Look, electrolytes, some of them are ionic, some of them are molecular. The question said molecular. What are the molecular electrolytes? Acids and weak bases. Strong acid, and weak base. Very good. HF, it's a weak acid. Oh, mister, how do we know if it's weak or strong acid? Even if it's acid. Okay, later I'll give you a list that contains all the acids and bases. Okay? تعورد دكاو لسه جواني دبي هر هميان لبركي بجواني زوج آسانة. Believe me, this is nothing. يعني هسه ليت ببرسم يك دنيا ناوي بمعنى دبره يي أكتر وفيلم ويوتيوبر وتيك توكر وباشاي خم ونازانم أو نامي ناوا كان يبلم شيخ نايلون ونازانم أو ناوا بمعنى أنا تهم لبره إذا أولي استرجع بركة رحمة الله بيد ظلم تليسكا. Okay, don't worry. This is a weak acid molecule. How about this glucose sugar? It's a non-electrolyte. What is this? Glycol, non-electrolyte, but it's a polar. Okay, but we need the electrolyte. C2H5OH, it's an alcohol, so this is non-electrolyte also. The correct answer is A. A is the correct answer. This one, a molecular compound that is non-electrolyte. Non-electrolyte. Okay, mister. We have two kinds of the non-electrolytes. Some of them are polar, like alcohols and sugars. Some of them are non-polar, like benzene, kerosene, and so on. Okay, the family of the non-electrolytes. Alcohol, it's a non-electrolyte, but it's polar. No problem, it's non-electrolyte. Good. Glucose, non-electrolyte. Glycol, non-electrolyte. All are correct. Very good. Okay, these two questions are really wonderful. We have two of the most wonderful questions. Look, which of the following dissolves in water? What mean by this, dissolves in water? It means it's a polar substance. And its aqueous solution conducts electricity. Again, this one, it means it must be electrolyte. Good. Okay, electrolytes can be molecular and ionic. The question didn't specify the main group of the electrolyte. It just said which of the following is the electrolyte. No problem. Look, HF, it's a weak acid. This is sugar. Okay, we know this is non-electrolyte. NaCl, it's a salt. Later I'll tell you how to recognize the salts. There's a wonderful trick to identify the salts. Don't worry. As I say, take yourself time, okay? You will have enough time to memorize all the acids and the bases, then the ions, then you will identify the salts very easily. Don't worry. Both are electrolytes. So the correct answer is D, right? But what's the difference between A and B? A and C, I mean. If the question said which of the following is a molecular compound, then only the weak acid is the correct answer here. But if the question said which of the following is the ionic compound that is electrolyte, okay, only C. But now the question only said which of the following conducts electricity, both. But this is molecular, this is ionic. Look at this question. Which of the following is an ionic compound? Ionic compounds are strong bases or that dissolves in water. Good. HF weak acid, no. It's a molecular compound. Sugar, no. Sucrose, no. Salt, potassium bromide, it's a salt. So this is the correct answer. C is the correct answer. Kata agabetu au classification dabar bihi cheshad namine. What comes next? List of the acids and the bases. Kaka on de bilwala barki basha jani man رجع أو خوالي ذكرني يعني ناوي خود دبير سلبو بولي دوازدي أو إلى بينك. You need this table. This is extremely important. Inshallah, next lesson I'll explain all of them. Don't worry. تاواني دهاتون. أخواتان دسبيرم. هر شاد من. أخواتان لقل.